Hi folks, welcome to Astronomy Live. I've got a spicy topic to cover tonight. Apparently, YouTube is blacklisting me. We're going to get into that in a minute, but first I've got another topic to cover here. And then later on we're also going to talk about a new program I'm creating for tracking asteroids, comets, solar system objects, and aligning them in your images automatically. But first, let's talk about what you're looking at right now. These are images from Discover. Its EPIC camera pointed at Earth. This was back in 2015 when it recorded the moon transiting in front of the Earth. And right away I'm sure people are going to say, that's fake, that's CGI. And it's a little fake because I ran the images through NVIDIA's super slow-mo AI algorithm to try to see if I could come up with a smoother video. Because the frames were taken a little bit far apart, so the original footage is a little choppy if you just run it as individual frames. But NVIDIA's super slow-mo AI algorithm is pretty good at smoothing out the rotation of the Earth, but as it turns out, not as good at predicting the motion of the moon, which is why it jumps like that. And when the moon starts to come over the Earth, it really gets kind of squirrely there for a second. So, on the whole, I think that the algorithm would be a good solution for producing smooth rotation videos of the Earth if the moon wasn't transiting in front of it. If you took the moon out of the equation there, I think that would work a lot better. But if you look at the original images, this is what they look like before I did that. This is just the raw data. I converted it to 8-bit images, and you can see the moon there transiting across the Earth. So people, flat earthers and others, will still say this is fake, of course. One of the complaints I heard most frequently about this was that the clouds don't appear to move. The clouds are static. Yeah, they're just using a static 3D model for the Earth there, you know, and every day maybe they change the clouds, but, you know, over the course of a few images, the clouds don't appear to move. That must mean it's fake, right? Well, are they really not moving? How would you know? I mean, the rotation of the Earth is pretty quick there compared to the movement of large cloud systems. So how would you really know if the clouds are moving or not? You need to stabilize for the Earth's rotation. And the one way you can do that is to reproject the images, and that's what I did. I wrote a little program I'll show you guys, and I'll throw a link in the video description afterwards, to a program I wrote to reproject the images. It's very crude, it's very basic, it's not the best way to do it, but simply taking the pixels from the original images, because these images were available in HDF5 format, which is a high bit depth format that also has a lot of very useful metadata, like, for example, the latitude and longitude of every point on Earth in the image. So I ran it through a program I created to reposition the pixels based on the latitude and longitude to basically compensate for the rotation of the Earth and reproject it kind of like a map. And you can see that here. The reprojected images, obviously it distorts it a bit, and the way I did it is pretty brutal and basic. It's not the proper way to reproject images, but it's functional enough. You can see clearly the clouds are moving. So yeah, it's not fake, and the clouds actually are moving, and they actually do match up with weather satellite images from that day if you look that up. So yeah, that will be in the video description. Just a little fun there to talk about that. We're also going to now move on to one of the main topics, and one of the reasons I really wanted to do this webcast today and not wait, because I don't know how long the situation is going to stay like it is, and I want to document evidence of what's going on YouTube right now. Certain channels seem to be getting blacklisted, mine included. So I have here an incognito window, browser window, searching for Falcon Heavy Astronomy Live on YouTube. My first Falcon Heavy video from the original Falcon Heavy demo mission is my most popular video on my entire channel. It has the most views of any video, and all of my Falcon Heavy videos are somewhat too highly popular. And yet, if you search for Falcon Heavy Astronomy Live from the US on YouTube right now, what do you get? A bunch of videos from other people. I do notice and I think this might be important too, that all the top results are verified accounts. Deep Astronomy, space videos, NBC News, SpaceX, space videos, SpaceX, so on and so forth. You have to scroll quite a ways till you start to get non-verified videos. And finally, you start to find some of my footage after you scroll down quite a bit. But you really don't find many results. You start to find other people talking about me. This is a Flat Earth channel that has attacked me, another Flat Earth channel that has attacked me. So you'll find plenty of those results, but you won't find too many of my videos. Okay? Let's try SpaceX Astronomy Live. Again, this is what happens if you search for it from a US IP address with an incognito window. So the incognito window prevents YouTube or basically takes away the search history. So it's not biased based on a search history here. This is just what YouTube will spit up to you if you're a brand new user or you don't have an account and it's not tracking what your likes are, what your favorites are, what channels you're subscribed to. If you're just, new to YouTube, or you're just a casual visitor looking up SpaceX videos, and maybe you heard about me and I film SpaceX launches a lot, and I film SpaceX satellites in orbit and all this stuff. You search SpaceX Astronomy Live, yeah, my videos don't come up in the top. You have to scroll till you start to find my videos. So that's odd, isn't it, guys? Now, you might say, well, yeah, we know that they are promoting verified accounts. We know that YouTube is actually publicly stated they are promoting trusted sources. Now, they have a trusted sources list, and they are trying to push down search results for Flat Earth and replace it with search results from mainstream media, from NASA, from just trusted sources, even other verified accounts like Deep Astronomy. I'm sure Everyday Astronaut would come up here too at some point. But this is really suspicious to me, not only because I'm getting pushed down in the search results from what I can tell, but here's the real interesting key. If you want to find out if a channel seems to be getting blacklisted, if you have a VPN, log in under an account or under an IP address that's outside the United States. Yeah, if you reverse it to Astronomy Live Falcon Heavy, I'll come up. But some of these search results don't bring me up, which is really weird. Here's the really interesting thing, okay? So I'm logged in now on my VPN. I'm connected to Ireland, okay? These results I pulled up already when I was still in the US, when I was connected to the US. Now I'm connected to Ireland, okay? Let's run the search again. Same exact search. Oh, look at that. Look at that. Astronomy Live, Astronomy Live. One of my videos on somebody else's channel, one of my videos on someone else's channel. Astronomy Live, Astronomy Live. There it is, 398,000 views. SpaceX Astronomy Live. Let's run that search again. Oh, what do you know? There's my video on someone else's channel. This is Red's video, but we filmed that launch together. My video on someone else's channel. There's my channel. I start to come up. Same exact search, totally different results, where I'm not apparently hidden if you're viewing from other countries. But if you're viewing from the US, it seems like I'm getting, I don't know, suppressed. It's really strange, and I've seen this with other channels complaining about it too, and I kind of wonder, is this happening? I mean, why would this be happening, first of all? Let's address that. Why would this be happening? Yeah, if you reverse the search, it doesn't necessarily act the same. But I'm finding on some searches I am apparently blacklisted in the US, and it gives totally different results in all other countries. If I connect to Canada, if I connect to Ireland, I get totally different results. I get results that I actually show up. So why am I not showing up in the US? When you flip it around, do Falcon Heavy Astronomy Live, okay? Or SpaceX Astronomy Live. If you're in other countries, it'll come up. If you're in Holland, if you do, this, it'll come up. But if you're in the US, it's a real problem. So this is the key. If you want to find out if a particular channel is being suppressed, search for it with a VPN in the US and compare the search results when you connect to another country, and maybe even a close by country like Canada, okay? I did the same search, Falcon Heavy, Red's Rhetoric. I'm not going to disconnect from my VPN right now because it would probably screw up the stream. But yeah, it works fine for Red's Rhetoric, which is good. If I do Falcon Heavy, Red's Rhetoric, his videos come up, his channel comes up, his latest videos come up, it's all fine. And if I were to disconnect, because I've tested this, if I were to disconnect from the VPN, or if I were to connect to a US server, it would give the exact same results. It does give the exact same results. There's no difference. But on my channel, there's a huge difference. So yeah, from Holland, you're going to be fine, probably. But for me, from the US, it's a strange issue. When I connect to a US IP address, my channel doesn't come up when I search for it in certain ways, like Falcon Heavy, Astronomy Live, SpaceX, Astronomy Live. I have to scroll and scroll to find my channel. But if I connect to another country, it comes up right away. It's not just a YouTube, I mean, it is a YouTube issue, but it's a YouTube issue that's specific to the country, Poe, because I can connect to another country's VPN, or through my VPN, and suddenly the search results change. So what's that all about? They're obviously manipulating the search results for US users. Maybe they're going to change that later, and maybe it won't be inconsistent anymore. Maybe it'll be worldwide, but it seems like at the very least they're rolling out changes in the US. So it's really strange. It's only certain channels. And I kind of wonder, I'm just wondering out loud here, because what would the reason be, right? I mean, I'm not a flat earth channel. I know they're talking about suppressing flat earth in the search results. They're saying that openly. I'm not a flat earth channel. Did their bot misclassify my channel as a flat earth channel? Maybe. Are they taking issue with me subscribing to certain other channels? Because this is the account I use to subscribe to channels I just want to watch. And I don't get into politics on this channel, but I subscribe to channels that maybe YouTube doesn't appreciate. I subscribe to gun channels, for example. I'm a gun enthusiast here in Florida, and that's perfectly legal here, but maybe YouTube's got a problem with that. So I don't know. I don't know if it's because of channels I've subscribed to that YouTube has flagged me, or if it's just that YouTube's bots have misclassified my channel as a conspiracy theorist or flat earth channel or something. I don't know. But there's something going on here, something very screwy with the search results, and it's not just my channel, it's others as well. Steven Crowder put out a video earlier today talking about this, and somebody in the comments pointed out it's the same deal. If you search for Steven Crowder in the US on YouTube, you'll find a bunch of videos about him from other channels. If you search for, and I think the search result there was, or the search terms were Steven Crowder changed my mind, it's one of his video series. It doesn't come up in the US. It's a bunch of videos about that video series, but it's not his videos, unless you're outside of the US, or you connect to an IP address outside of the US through VPN. Then suddenly it comes up. So yeah, and keep in mind, the point I'm making here is not that it's absolutely impossible to find my videos. It's not, but they are suppressing me in the search results with certain terms or certain search combinations. Yes, you can find a way around it. That's not the issue. I'm not saying it's absolutely impossible to find my channel, but they are manipulating the search results in the US specifically, which is rather interesting because you can see it happening. You can see which channels are being affected and which aren't just by running some searches and comparing them from one country to the next. So yeah, subscribe channels may be a part of the algorithm. Oh, that's strange. Why did... I don't know why it suddenly switched my window there. I'm going to go ahead and close this. I don't need that anymore. So yeah, I don't know if it's because of channels I've subscribed to or whatnot, but this is also why I'm running it in an incognito window here, so that it's not factoring in my subscriptions or my account in giving me these search results. This is from a blank, unsigned in, signed out, blank account, right? And yeah, it's an issue. Yeah, and that might be it, Poe. Poe says, don't say words flat earth in your videos. YouTube creates virtual tags from your speech and closed captions. Yes, they do create automatic closed captions. Maybe it was something I said that they picked up on in the closed captions. I do wonder why, other debunking channels like Red's Rhetoric doesn't seem to be affected, and I'm glad it's not. I'm glad Red is fine, but I'm wondering what it is about my channel that it's latched onto it. It might just be just random noise in the bot, random misclassification. It saw both Red and myself talking about flat earth, but it correctly ascertained in Red's case that he is against flat earth. Now, Red uses much more negative language against flat earth than I do. Maybe that's why. Maybe it senses that I'm not negative enough in my tone when I talk about it, and therefore it thought that I was actually a flat earther. Just a thought. And I've probably done it to myself again. At this point, there may be no getting out of the hole that my channel has been dug into. I don't know. Yeah, maybe tags are involved. I don't know. There's a lot of possibilities, and it's going to be hard to eliminate what it is. Because even if I go through and let's say I nuke all of my tags right now, and I don't know, there's nothing I can do about the closed captions. There's nothing I can do about my previous videos other than just remove them. But I'm not going to remove all the videos from my channel just because YouTube's bot may not like me. So, I don't know. It's really strange. It's really a problem. And we'll see how it goes. I will keep an eye on what's happening with other channels. I know Steven Crowder's fighting it. I know a lot of you guys may not appreciate his politics. I get it. But I'm just going to watch that battle because he's trying to fight YouTube on this very thing right now. And it'll be interesting to see what information he's able to get out of YouTube. As a very large content creator, obviously, he's more likely to be able to get a hold of someone who actually knows what they're talking about at YouTube. We'll see. He's supposedly going to have a talk with somebody. There's somebody he's supposed to be talking to shortly about that issue. So I'll keep you guys updated, but I found this out today that, yeah, my channel is definitely having screwy search results and is being suppressed in the search results, depending on what you search for and where you search for it. If you're in the US, you might be getting, you might be finding that it's actually a little harder to find my videos than it should be. So, okay, let's move on to more fun stuff. I've got here a program that I've been putting together since I tracked or attempted to track the interstellar comet Borisov. You remember that live stream I did a matter of days ago, or I guess now over a week ago, where I attempted to track the interstellar comet Borisov with my telescope and took a series of images at its expected location. The problem is that Borisov is moving from frame to frame, but not so fast that NeoTracker really makes sense. NeoTracker is the program I wrote to be able to track solar system objects with telescopes, but it works best for near-Earth objects, near-Earth asteroids, things that are relatively close to Earth. So, the solution, one possible solution, is to align the images based on where the comet is predicted to be in the image, using astrometry. Astrometry is the measurement of the positions of the stars and determining the coordinates of each of the pixels in the images. So I've already tested it a little bit. It's coming along. There's one more thing I need to do to add to it here, and that's what I'm going to work on and show you guys. And then hopefully it'll be done and ready, and we're going to test it on some old images I took of the SpaceX Tesla Roadster from 2018 as it left Earth. As it left Earth, it was still close enough that parallax from the rotation of the Earth actually caused the apparent trajectory of the Roadster to appear to be an arc instead of a straight line. And so that's a very demanding situation for this program in a way, because it has to account for the observer's position on the Earth and the parallax induced by the rotation of the Earth. So those are the equations I'm putting in right now. Once that's done, we're going to run those images through and see if it really does work well. I ran the comet images through. The comet's still far enough from Earth, and probably will be throughout the encounter, that the exact position on Earth doesn't matter. You can just grab the coordinates from a geocentric perspective, the center of the Earth, and it'll be close enough. And so running it through that way, I unfortunately did not see the comet even when I stacked the images together. So the Tesla is far out there now. It's far away from Earth. It already passed through the orbit of Mars and is on its way back to the Sun. In fact, I think it already completed one orbit? It was getting close to it if it hadn't already completed one orbit. I think it had recently completed its first orbit. But Earth, of course, is no longer at the position that Earth was at when the SpaceX Tesla left, the SpaceX Falcon Heavy second stage and Tesla left Earth. So it did not come back to Earth per se, just to Earth's orbit around the Sun. So it'll continue orbiting the solar system for millions of years to come. But I did get images in the initial 10 days or so after that launch, and the first day's images, like I said, were really impacted by the rotation of the Earth. And later tonight, let me point that out, later tonight there will be the Starship webcast on SpaceX's channel. Please, guys, everyone go check that out. They've already got the link up on their channel. Their stream is getting ready to go live in a few hours. I'll definitely be watching with all of you, but I'm not going to stream that live on my channel. I'll just I'll turn off the stream here, and we'll just watch it on SpaceX's channel. Or, if you prefer, I would assume Tim Dodd, Everyday Astronaut's probably going to do something for it too. Let's see. So right now, what I need to do is pull up a book that I frequently reference. It is Practical Astronomy with your calculator. Why is it not coming up? Ah, there it is. I'm trying to get my library of Google Books to come up. Practical Astronomy with Your Calculator by Peter Duffett Smith. Oh, I'm not signed in? I should be signed in. Why am I not signed in? That's weird. Okay. So you can get this on Google Books. I also have a physical hard copy as well. Okay, so, right. Need to plug in the equations for calculating for the parallax due to Earth's rotation. I've got p sine theta, p cosine theta. Oh yeah, we're going to need the hour angle, so we need local sidereal time. Did I not put that in here somewhere? Guess not. Guess not. Okay, so first step first, I need to get the local sidereal time to calculate the hour angle. Local sidereal time is basically star time. I'm pretty sure PyFM has a function for that. So I'm just going to pull that up. Yep. Sidereal time, parentheses. Okay, so I could have sworn that I had that in here somewhere, though. Ah, yes, I do. I've got it here. Okay, so just going to put it into this section. Also, back here, I've also got the processing programs for the Discover images I showed earlier, so I'll include a link to that in the video description. This program will grab all H5 files that are in a given directory, and it will automatically start processing them to reproject them using the coordinates, the latitude and longitude throughout the image, in order to see how the clouds are moving on the Earth by stabilizing the ground. Okay, so we got the local sidereal time there. So now we should be able to get local sidereal time, minus right ascension. So LST minus target RA. That will equal hour angle. So that'll be that. Okay, so then we need to calculate a factor called this delta. This will equal tan. Should this be a tan 2 or just a tan? I'm not sure. It doesn't really say, but I'm guessing. Is there going to be quadrant ambiguity with this? There might be. Yeah. I'm going to say a tan 2, and that's going to be e cos theta times math dot sine, and it's going to be our angle. Now, our angle should hopefully be in degrees currently, but it needs to be in radians. I think in degrees, not radians, so I always make my code less efficient than it should be by converting back and forth between degrees and radians. Then we close that off. We divide this by r cosine theta. R, oh, we need r. Distance, kilometers. We need target distance. Can I get that from PyFM? I can probably get that out of PyFM. Distance. Earth distance. Solar system bodies. It should, but that's going to be in astronomical units. Range. Okay, well, it's not a satellite. Body compute. Bodies with orbital elements. Oh. Optical. Mean distance from the sun. Yeah, that's just how you set the orbital elements. I'm guessing it's going to come up with Earth distance. Okay, so distance equals target dot Earth underscore distance. Okay, that's going to be in AU, astronomical units. I think I'm going to need it in kilometers, yes. And that's going to be what? That's going to be 149,598,000 kilometers. So distance is going to be that times this. Okay, that'll be distance in kilometers. Okay, so now we can come back to the formula here and complete it. It's going to be target distance times cosine of, what is that? Oh, that's declination? Yeah, it's declination, okay. And then it needs to be radians. And that's going to be minus p cosine theta. And it's going to be times cosine of the hour angle. Math dot cosine of hour angle. And it needs to be math dot radians hour angle. Okay, that should be delta. Apparent declination for geocentric declination. So, okay, so this is going to be target RA. We're just going to apply it directly. Equals target RA minus delta. That will be the parallax applied to the right ascension. Now we have to calculate parallax for the declination. It starts off the same. Actually, I think these functions are just regular atan. Atan. So this is going to be target deck equals. The reason I'm having to do this is that PyFM, while it is very good, gives you astrometric geocentric coordinates, but not astrometric topocentric coordinates, which is what I actually need. So we need to calculate for topocentric parallax, which is what we're doing. F dot cosine of the hour angle. Oh, they want the hour angle with, it's actually parallax applied to the hour angle. Angle prime is what I call this. This will be hour angle plus delta. Okay. F cosine F radians hour angle prime. And that will be times target distance times F dot sine F dot radians target deck minus P sine theta. Okay, divided by target distance times F dot cosine F dot radians target deck times. Oh, I might be having an issue there with that. I just have to be careful about my parentheses on these trigonometric functions. F dot cosine F dot radians hour angle. No. Okay, so now they want the hour angle without parallax. All right. So it's just going to be hour angle. And that's going to be minus P cosine theta. Alright, that's way too long for one line, but who cares? Close that all off. And that is the new target declination. Okay, so that should do it. That should theoretically complete the program. I'm now going to run it on the images from my first night of observing the SpaceX Tesla Roadster, and we'll see what we get. What's the azimuth and altitude of the Tesla? Right now, I don't know. You can get that from JPL Horizons, and that's the other interesting thing. The other point of this is in order to align the images based on the coordinates and the expected position of a given solar system object, you have to know the orbital elements of that object. The way this program works right now is it's designed to ingest orbital elements straight from JPL Horizons, which is a great service, a great system for getting accurate orbital elements of just about anything you want. So this is on OneDrive under what? Documents, Comet Stacker. Okay. So I'm going to paste the images in the directory with my program, and now I'm going to go grab the coordinates, or the actually the orbital elements for the Tesla Roadster. So here is JPL Horizons. If you just Google JPL Horizons, this is the page you should come to. The web interface is what you want. You can change the target, or that was ephemeris type. We're going to change the target here to Tesla. SpaceX Roadster. Change the location. Actually, what we want in this case is orbital elements. You can get coordinates, so you can put in your observer location. You can search for a location. You can search for your state. You can choose from a list of observatories. There's many different ways of picking your site. You can also just specify manually your latitude and longitude and get it that way. For now, though, I'm going to be getting orbital elements instead of an observer table. An observer table will give you the altitude and azimuth of the roadster at any given time. But keep in mind, guys, it's way too far away from Earth to be observable, even with a powerful telescope at this point. I was able to observe it for about the first 10 days after it left Earth, but after that it got too dim. So, let's see, center, sun, yes. Change the date, though. We need this on February 8th. And you have to give it a range, but it doesn't have to be a long range. 1 day. Let's see here. Let's do 1 hour. Universal time. Okay, so that gives you this down here. This stuff down here are these are the orbital elements for the Roadster. So I'm gonna just save that to the directory now as a plain text file. Download and save. Sure. Okay, it's giving me that. I'm gonna take that, put it in. Where did it go? Comet stacker. There we go. All right. Alright, so the way this program works, now it's the fun part. So we've got the program, the Python file in the directory. So we type Python, and then we give the name of our script, comet stacker 3.py. And I need to put in a system that shows you what you should do. Oh, I do have it there, okay. Good for me. So if you just type that in, it will say proper use, Python, cometstacker.py, elements.txt. That needs to be your orbital elements file downloaded from JPL Horizons. That output I just showed you just save that whole big file as a text file. There's an option to save it directly as a text file. And then your latitude and longitude. So for that, I need to look up what it was for T27 on the itelescope.net network. That was the telescope I used. See if I can find the coordinates for that. That was in Siding Spring, Australia, I believe. T27. Oh, did they get rid of T27? I think they got rid of T27. It's not listed anymore, but it's at the same observatory as these others. I'm pretty sure I used Australia, right? I kind of wish they had legacy listings, because I get confused sometimes. T27 is not New Mexico, is it? No, it's not. I'm pretty sure it was Siding Spring. And hopefully this will work. There's a couple of unknowns here, one of which is the fact that this was saved with iTelescope's CCD cameras, and I'm not exactly sure. I hope that they use universal time when they save the metadata on those images, but I'm not 100% sure of that. I think they do, but I'm not 100% sure. Okay, so they've got it listed in, okay, it's 24 seconds, 60 plus 16. I need it in decimal coordinates, so I got to do that conversion real quick. 4 divided by 60 plus 31. Okay, so the latitude is going to be negative 31.273. longitude is going to be 52 divided by 60 plus 3 divided by 60 plus 149. 149.064. Enter. Really? Oh, no, I forgot. I've got it looking for the wrong file extension. That needs to be something else. What is it? Fits, I assume? Yeah, FITS fits. Okay, try that again. Go. What's this? So we got an error. Second millisecond split. Warning, Radexis FK5 Victorical. Keyword is deprecated. Well, okay. Well, I'm not going to be the one to fix that, but line 116. So it's having trouble splitting the date and time from the observation data. That is probably a function of the formatting that their cameras use as opposed to my camera. I tested this on my camera data. However, there's a little catch here. You may have to fiddle with this thing if you're using it on your own computer and your own camera, because data observation might not be formatted the right way. So yeah, there is no data obs on the camera that actually took these images. Does not have a millisecond setting. So seconds, there is no decimal point. That's why this generated an error at exactly that line. So I'm just going to comment that out because we don't need to split it between seconds and milliseconds. It doesn't have that much detail on the date of observation. Okay. Float object is not callable. Oh. Really? Okay. It's on line 122. Failed to converge to the requested accuracy. Okay. So now it's having issues with the world coordinate system data, the astrometric solution. I kind of have a bad feeling that these images, yeah, I kind of have a bad feeling that the WCS data that I have on there is a bit duplicated, I suspect. What did it look for? It looked for RADEC sys equals FK5. Is that under the astrometry or is that under... No. Okay. This is the problem. Yeah. The problem is that there's two sets of WCS data embedded in this FITS file. iTelescope put in its expected coordinates of where I guess it thought the position was, but it's not what this program actually needs. There's another solution attached to the same file later on, but it's more accurate, but it's not looking at that. It is going straight to WCS entry, and that's with, was it AstroPy? AstroPy is pulling that. Darn it. Okay, so Yeah, this is an interesting conundrum. I'm in a catch-22 because I need the metadata of the date of observation. I don't need the kind of cruddy approximate coordinate solution that is on these files. What line did it fail on? Line 135. Okay, failed at line 135. Pixels. Instead of doing mode all, so this is, I think this is AstroPi's function, skychord to pixel. And it can do various things. It can compensate for, I think it can compensate for some distortions. I'm just going to use the core WCS data. We'll see how accurate this is. We don't actually need super duper accuracy because we're not trying to pinpoint the exact location of the solar system object in the image. We're simply trying to compensate for the motion from one image to the next. Okay, we want to represent the motion of the object over the images. Hopefully this will work. Hopefully. Let's see. .167. Okay, it's trying to split the seconds and milliseconds again. So this also, I forgot, this actually needs to get duplicated. This whole section right here, I need to comment this. This is eccentric parallax. That needs to get copied and put down here. So that needs to be here. I really should have set that as its own function, defined it as a separate function. I just called it twice, but whatever. Okay. What was the other thing I probably would need to do? Here, this needs to be WCS. Okay. At least we're getting different errors every time, so we're making progress, right? Oh. We tried to overwrite the file. Oops. Oh. Okay. Yeah. Okay. And that's on line what? That is on line 230 is where it saves. Okay, so it's just down here. So entry, what we will do is we will do this. We will do string will now be the file name will be that plus that plus that. Okay. Now I don't need that. That's redundant. Align dot fits. Okay. Now it won't try to overwrite the file names. That's always good. Thank you for stopping me. Date obs not found? What? Where? Huh? No. Date obs not found. When was date obs not found? Date obs should have been found. This disturbs me. Oh. It created a zeroth. Alright. Try that again. Yay! It's working. At least it thinks it worked. We'll see how well it worked. Okay, so it is now aligned the images in theory. this needs to be up here. There is a separate save function in here somewhere. I know you're here. Right to, yeah. The first image too needs to save under the new motif. Okay. Oh, one dot fits, a line dot fits. No, 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 no. Okay, that's all wrong. Okay, what did I do there? I did a thing. Oh. Oh yeah. Okay, I see. Now this needs to be dot split. Split by the period, and we just want the first of that array. Okay. Okay, let's try this again. Okay. All right, let's run it one more time. Hooray. Okay. Now, we're going to come into Deep Sky Stacker and actually look at some images. Hopefully this worked. So this is the first image before it was aligned. We're going to cut these, we're going to paste them under. Huh. That's weird. It's just weird. It's not aligning them properly. It's doing weird things. Weird things are happening. Sort of. Yeah. So the Roadster is here. This is the Roadster right here. But it's not doing what it should do. And I'm not sure why. I have a sneaking suspicion that it's the bad WCS data that's in these files that is just throwing everything into disarray. It's either that or it's getting something wrong with the orbit. But I don't think that's the case. Could it be because of the rotation of the images? Maybe, but I don't think so. This acts more like it's just goofed up. Probably from really bad WCS data. The first entries on the WCS of these files are not reliable. So, unfortunately, the only thing I can really do... The only thing I can do to fix it... So we've got two sets of coordinate data applied in these images. One that I trust, one that I definitely do not trust. And it's just moving it all around. Oof. It's just weird. I think it's just really bad WCS data, yeah. Huh. So, the only thing I can do is basically strip... Oh man, but that's the catch-22. If I strip all the header data from these files, then I lose the date of observation, which defeats the point. If I don't strip all the data, it pulls the wrong WCS data and just goofs everything up. And it's a problem for these images in particular because iTelescope embeds a rough coordinate set. And that's not good enough. I need astrometry.net's coordinates to be the coordinates that are used by the program, but the program seems to be pulling something else. Okay. Never had to edit a Fitz header before. But I might have to. AstroPi. Well, I can edit it with AstroPi. Well, that would be handy. Fix my problem all at once. Okay. Let me look in AstroPi. Is there a way to have it skip the first WCS information it comes across? Let me try something. Where's it getting the WCS? WCS entry. Let's try this. I don't think this is going to work, but try specifying the HDU. Okay, that generated the same wacky coordinates as last time. Let's now try switching HDU to 1. This probably will not work. Likely. Yeah. Yeah, there's no HDU1. Okay. Fine. So I just need to edit the header. That's all there is to it. It's a real catch-22, this one. This is not the simple example I thought it was going to be. Yeah, that's how you... Okay. Oh, okay. We can do that. For small operations. Can set val. How do you get the file object in the first place? Oh, get package data file name. Okay. So under AstroPi utils, we have our AstroPi. Yeah, utils. Okay, I need this. Okay. Get package data file name. Okay, so I can now set val. Can I get val? I can get val, can I? there's got to be a way to get the get val. Yeah, there's a get val. Okay. Yeah, this is way more complicated than I thought it was going to be. So, the problem is, here's the coordinate set from my telescope. This is what it's actually pulling, which I don't trust necessarily. I don't think that's super accurate. Then down here suddenly you have the start of astrometry.net WCS solution. And down here you have a totally different set of RA and DEC coordinates. And you see here it's negative 27 degrees, 0.06. Up here it lists the object's declination as negative 26 degrees and 55 minutes. So it's obviously it's not quite accurate, because I trust astrometry.net way more. How is it even getting a pixel scale? Is that up here somewhere? Pixel width in microns. Is it calculating from the focal length? Must be? I don't know. It's not good. Okay, so yeah, it's a real pain in the rear because I basically have to there's no way for me to edit it in this program. Okay, well, tell you what, guys, let's try a backup plan because this is a real catch-22. I'd have to edit all this stuff for each one of these files. And maybe I could reroute the data from astrometry.net WCS into this. I don't know. But I'm not going to try to fool with that right now. Instead, let's see. I know I've got some other solar system objects I could just test this program on. Let's see what else we got. Oh, come on. Those are satellites. I need something else. Where's the Halloween asteroid images? I know I've got them in here somewhere. Here it is, TB145. Okay, cool. Alright, so do we have it there? Probably. Let's see. Come on, where's the calibrated images? Okay, there we go. Yeah. Oh, this'll work, I think. Okay, let's just do 2015 TB145. So I'm going to copy all these images. This will be a nice demonstration because I've got a ton of these images. The Halloween asteroid from 2015. Okay, we're going to I'm just going to nuke all the Tesla images for now. Okay. And I'm copying over the TB145 images, and then I need the orbital elements for TB145. So that's going to be target body. So now we just pick new target bodies. 2015 TB145. That was an asteroid, correct. And this was October 31st, 2015. Okay. I've got that, and Comet Stacker. We're going to paste that in as elements txt. Okay. And I'm going to pull this over here. Sorry, don't want you guys seeing my latitude and longitude. This was something I shot from home. So oh, right. And the pattern for this is actually fit. And actually, might have a little issue. Oh, the calibrated files don't have the... Oh, no. Yeah. They don't have the metadata attached. Darn. Okay. Huh. That's an interesting issue there. Okay. Okay, that's another issue. So my camera takes single shot color pictures. This is really not designed for that. This is designed for monochrome at the moment. I could fix that, but the other issue is that the calibration process breaks the metadata. That's interesting. So apparently Deep Sky Stacker calibration messes things up. Okay, this one. Oh. Okay. Yeah. Okay, so the other issue is these raw pictures I don't have astrometrically solved, but I can fix that. Let's just do a test on a couple of them here. Don't have to do the full set, because to astrometrically solve the full set I would need to reboot the whole computer into Linux. But we're just going to do a test. Let's see. Astrometry, give me a new upload. Okay, it only disconnected it for a short period of time. Just waiting on astrometry.net to solve these images. Hopefully that goes okay. It's working on that. I'm going to nuke those out of this directory. Okay. Any day now. Okay, that one's done. That one's still running. Oh, those two are done. Okay, got them. All right, so now I can save these. Okay, those are saved. All right, hopefully this will work. Okay, fits distortion. No, it's having trouble with the... I should have done that stuff to it. Okay. Get rid of all this garbage header stuff. Okay. Huh. It's crashing out at the WCS entry. WCS distortion, paper lookup tables, and SIP distortions only work in 2 dimensions. Has detected 3 dimensions of the core WCS keywords. Using the Nexus quark. What is the deal? What is the deal with that? Oh. Huh. Well, we got another issue anyway. There's no... Why? Why is there no... What in the world? There's no date or time information on these images. Why? Yeah, and it doesn't... I think it doesn't like that it's a color image is the issue there. But more importantly, why... why are these not... Why do these not have date and time data? Okay, I guess 5 or 4 years ago when I took those images, something really screwy happened with the headers. They're just not there. TB 145. Yeah, if this is the raw... Yeah, these are the raw images and there's no... What, there's no header data? Well, there is, but somehow it got screwed up by astrometry.net then. How's that possible? Huh. Oh, did I? Maybe I uploaded the wrong files? I don't know. In any case, it doesn't like them being having a third dimension, which 3 layers for the colors. Doesn't like that, I think. It's interpreting that wrong. I need 2x2 band images of something moving in the solar system. Okay. Alright, well, let's just do this. Do I not have comments? I need my images of Borisov. Where did I put those? That's the question. Might be on my other laptop. Yeah, I think it's on my other laptop. I'll be right back. So, a number of issues have come up, but that's how programming goes. First of all, the telescope images have astrometry data that is not accurate enough, and it seems to override the astrometry.net astrometry, which is not good. I'm not sure how to fix that problem. I could strip out all the header data pretty easily, but doing that would erase the metadata for the date and time the image was taken, which is necessary. So I'm going to have to figure out a solution for that problem, but not on stream. Issue 2, I have images that I could use, but they are color images, and it doesn't seem to like that, which I'm not surprised. I didn't think it would like that, but they're one-shot color images with 3 different channels, and it's really not designed for that just yet. It's designed for monochrome images, which actually most astrophotography is. So, yeah, some issues to work through. If I can get my laptop to come up here, I'll see if I've got the images of Borisov to run in there. I don't think Borisov is detectable in those images, but I just want to verify the program works. Alright, so while I wait for that, any questions in the chat? Inlay the RGB, yeah. Yeah, I should do that. Come on, what's wrong with this? My laptop does not want to listen to me today. File Explorer is just locking up, and I just booted it up. That's great. What's going on? Ugh, the whole laptop is just frozen. Okay, so Explorer just crashed for no reason. That's nice. Good job, Windows. Good job, Microsoft. Well done. RGB died a year ago, at least. Well, lots of things died a long time ago as far as my stuff is concerned. I've got an SBIG ST2000. I'm using CCD soft to acquire the images. So, yeah, doing things the old-fashioned way. Okay, thank you for not crashing this time. That's peculiar. That's really peculiar. Where's all my image data? Oh, that's right. I had to swap to the other laptop. Wrong laptop. Okay. I'll be right back again. Alright, finally. Got the images of Borisov. So, alright. So now I need to go back here. File extension on these are actually going to be .new, but they're FITS files. And then I need the orbital elements from Borisov. Okay. So I deliberately made my latitude and longitude a little bit wrong so that I don't dox myself, but this should do it, please. No. Okay. That already exists. How does that already exist? Oh, yeah, okay, I see. That's it tried to overwrite the first file with the second file. I need to change the motif for that. Hooray! It did it. Okay, so in theory that should have worked. It looks somewhat reasonable, but we're going to find out. We're going to clear list. Don't save changes. All right. So these are the images from the Borisov webcast. Still looks a little goofy to me. Huh. Yeah, that does not look right. Okay, let me try something. That does not look right. Let's try this without the top-centric parallax. Let's go with geocentric coordinates. Let's see if that works. Oh yeah, that looks much more reasonable. So it's printing out the offsets. Looks much more consistent now. Okay. Hooray, that's what it should do. Okay, so it's gradually moving the images down based on the motion of the comet. And the coordinates of the image. And there was that airplane that flew through one of the frames. So it works. The basic program works. I still got to tweak some stuff, obviously, but it does work. So, yeah, I don't know if it's ready for release yet, but at least the basic principle works. Hopefully I'll have it fully operational by the time Borisov is bright enough to actually see, because I've already tried stacking these images and there's just nothing there. But yeah, alright, so I'll keep working on it. And looks like we should be looking for SpaceX to go live soon. SpaceX presentation. Yeah, people are commenting on it, but where's the actual SpaceX channel? Why can't I find There we go. Okay, so yeah, they're set to go live in about 2 hours at 9 p.m. Eastern. So check that out on SpaceX's channel. I'm gonna sign off for now and get ready to watch that, and I'll see you guys next time. Hopefully next time we're able to track Comet Borisov. It'll actually be bright enough to see. So later in October, mid-October to late October, hopefully it'll start to get bright enough to actually detect. And it peaks in altitude from here in Florida in mid-November, and so that's about as late into the year as we'll be able to get it. By the time we get into December, it's going to start to descend too close to the sun to see from here. So Stay tuned for that, and thank you all for watching. Clear skies, folks.